Well, welcome back to AP Psychology at What Women. I'm Ms. Del Savio, and again, Mr. Temple will be filling in for me this week. If you have any questions that I need to personally address, you can contact me via Canvas or Synergy. Please do not use the .NET or the Google email. I don't ever get into it, so it's best just to contact me through Synergy or Canvas. Okay, I'm going to backtrack a little bit. Each class ended at a different place yesterday, but you should have all reviewed what psychology is, and you defined it as the scientific study of behavior and mental processes. We went on to define what critical thinking is and why it's needed so that we can reduce our biases, including hindsight, overconfidence, and confirmation bias. We moved on to the scientific method that defines psychology as a science, including the role of peer reviewers in research, looking at what a theory is, how that differentiates from a hypothesis, and what it means to create a hypothesis that's falsifiable. So we're going to start from that piece of it, from that right after the falsifiable hypothesis, and we're going to move on to talking about operational definitions of our variables that are part of our hypothesis. So we started with the hypothesis when sleep deprived, people will remember less from the day before, and we're going to stick with that one. And I really asked you to first define the variables that are being studied. And we should have come up with the two variables from this hypothesis that are being studied are sleep deprivation and, of course, memory, very specifically memory from a prior day. Operational definitions of our variables are basically a way for a researcher to say, this is how I manipulated the data. This is how I controlled the data. This is how I measured the data. And they create these procedures. And in the procedures that they write up, there are definitions of the variables. They're called operational definitions, very precise parameters about how these variables will be collected, measured, or controlled. Now, these operational definitions is pretty important since we're going to be looking at the scientific procedure. We want to be able to quantify them. We want to be able to put them into numerical terms. If I say that sugar makes people hyperactive, well, you're going to need to tell me how much sugar, what's the amount, what's the number, and how many times or what behavior am I specifically looking for when it's hyperactivity? Is it getting up out of your seat more than 6 times, or the number of times you get up out of your seat, whatever it might be. So quantifiable is really important. So in the context of the hypothesis that we've been using, what does it mean to be sleep deprived, and how will you test memory? And before you go on, and we are going to do an exercise with that if you haven't already, before we go on with that, let's go ahead and just make sure you understand why operational definitions are important. In a study, and part of the scientific process is that once you conduct a study, researchers will likely publish it, and then other researchers will go about, because this is a self-correcting method, and try to replicate it. Replicate meaning repeat it. And you can't replicate a study unless you know how it was conducted. I can't replicate a study about, let's say, sugar and ADHD unless I know how much sugar you made somebody consume, or how much sugar you watched somebody consume, and how you measured hyperactive behavior. So it's really important with operational definitions that we understand how important they are, why they're important, and then, of course, how to operationalize a variable. So what we're going to start with is to practice, before we go back to our old hypothesis, let's just start with how can you quantitatively measure anxiety? So levels of anxiety, you may or may not know this, are often characterized by increased activity in our nervous system, specifically something called our sympathetic nervous system. Levels of cortisol and adrenaline get flooded into our bloodstream, and we could actually draw blood on somebody and see how anxious they might be based upon those levels. The other way we could operationally define anxiety would be on a self-reported scale of maybe 1 to 5. And maybe you give somebody a survey and you ask them a number of questions, or even just one question, and they might say, I'm not at all anxious, I feel not at all anxious, all the way up to I feel extremely anxious. And you as the researcher would assign not at all anxious as being 1, very low anxiety, and extremely anxious as being 5. Now, this is an example of what we call a Likert scale. So it looks like Likert, but it's actually pronounced Likert scale. A Likert scale is a scale that's often used, and I'm sure you've come across them in questionnaires or surveys, and they're used to quantifiably measure behaviors, measure attitudes, and measure opinions. So while you're writing that down, some of the ways in which or reasons that people might use a Likert scale is to, for example, assess the severity of somebody's symptoms. When you were younger, maybe you weren't going to give a number 1 to 5, but they'd give you a happy face scale from really unhappy to really happy, and you'd have to say where your pain was. Okay. Agreement with statements. Totally disagree or extremely disagree or strongly disagree to strongly agree. Again, the Likert scale or the questionnaire might not say 0, 1, 2, 3, 4, 5, but the researchers are going to be assigning number codes that correspond to your answers. Maybe 0 being extremely disagree to 5 extremely agree. The other way in which Likert scales might be used would be when you're trying to assess behaviors, a number of behaviors, a number of times, a number of hours, a number of days in which a person engages in a behavior. If you want to take a look at, for example, number of hours studied and GPA in a particular class, a teacher might collect the number of hours a person studied over the course of a 2-week period for the final exam. And of course, they would be then also looking numerically at their grade. So these are all examples of Likert scales, lots and lots of other examples as well. I'm going to show you an example of a Likert scale that's used to assess somebody's level of anxiety disorder. Generalized anxiety disorder is a disorder that's considered a disorder if a person is overall anxious about lots of things, not just being late to work, but whether or not they are going to get sick, or whether or not their kids are doing okay, or whether or not their car has a dent on it. Anxiety is just through the roof. And so generalized anxiety disorder has to be measured, so definitely clinicians want to know if they should treat it. And one way they do is through this Likert scale. It's a 7-question scale, and you can see there are 7 questions on here, and the person would respond to them, and then all their scores would get added up, and based upon their score, they may or may not be diagnosed with generalized anxiety disorder. So that's just an example of the use of a Likert scale to measure a variable like anxiety. So I'd like you to just practice, create your own question, making use of a Likert scale question to assess a person's sleep habits. I would not spend more than a minute or 2 on this, so I'm going to pause the video now. Okay, coming back to this, hopefully you've had a chance to at least understand or practice a Likert scale creation question. And now we're really going to go back to how will you operationally define, you don't have to use a Likert scale, but you could, but how will you operationally define sleep deprivation and memory, specifically the previous day's memory. Now for this particular exercise, I'm going to suggest that you are a researcher and you are doing this research in a laboratory setting. So you're going to control sleep deprivation and you are going to measure memory, okay? So you're not doing a survey on it. You're not going to have to do that. But I do want you to think, if you were putting people in a laboratory setting and you were going to see the effects of sleep deprivation on memory, how would you operationalize sleep deprivation? How would you operationalize memory? And give yourself a good 5 minutes to do this, and then let's come back. Okay, hopefully your operations were quantifiable, your operational definitions were quantifiable, and I'm going to show you what I did. Obviously, there's no single right response here. I operationalized sleep deprivation, as less than 4 hours of sleep in the 24 hours between learning a list of 30 items and being asked to recall as many items from that learned list as possible. That is a very precise parameter. Notice it's quantifiable, less than 4 hours of sleep. That's how I operationalized sleep deprivation. And I gave very specific procedures for that. As for memory, or previous day's memory, I said number of items correctly recalled 24 hours after first seeing items. Okay? Again, it's quantifiable. I can simply look at the people who I gave sleep deprivation to and others who I allowed to sleep their normal night's sleep, and then give them a memory test on the items that they had seen the previous day and count how many items each person remembered from each group. I'll probably take the average of those people who were sleep deprived, the average of those people who were not sleep deprived, and compare those averages. Okay? So this is a reason for operational definitions. So we're going to move on in the scientific method, and we're going to look specifically at different types of non-experimental research, some of the benefits and limitations of using it, the role it plays in the scientific process, and some of the features of non-experimental research. Now, when I say non-experimental, these are methods where a researcher will observe and measure the variables, like let's say sleep deprivation and memory, in their natural state. They don't manipulate them like you did in your experiment or control for them. And often you might get descriptive, qualitative data as well as quantitative data. Sometimes we use non-experimental methods because we don't want to do an experiment yet. We really just want to see, is there a relationship? Let me just look at these variables. Is there a relationship between them? And it's a step before a hypothesis is tested, often. So these methods differ greatly from experimental methods, and the main way in which they differ, not just in terms of the way in which you conduct them, but the end result, is that non-experimental methods cannot establish cause and effect. I cannot say for certain if I observe that people aren't sleeping very much and I observe their test scores aren't very high, I can't say for sure that lack of sleep is causing poor performance on the exam. I would have to put them into a laboratory and do all that testing. So non-experimental methods differ greatly from experimental methods for that reason. However, we still use them because they have a lot of benefits. And we'll have you write down what is in italics here. Number one, there's no ethical concerns. I'm not going to deprive anybody of sleep, give anybody a pill that might alter their consciousness, potentially manipulate them and deceive them. There's just no ethical concerns when you look and measure variables in their natural state. You're not manipulating or controlling anything. Number two, because you're not doing that, because you're not bringing them into a lab, it's very affordable, very inexpensive way to gather information about the relationships of variables. You can also analyze past events, right? Because if you're doing an experiment, you're looking at the current time period. You're looking at what's happening right now in real time. But if you use non-experimental methods, you can take a look historically and see, hey, what's the effect of smoking on birth weight of babies? And the big one is called ecological validity. Now, I'm going to go in the next slide to talk more about ecological validities, and we'll define it, but I'm introducing it here. You can just write it down, just the word, the terms. But ecological validity means basically the findings, how applicable they will be in the real world setting. And obviously, if you're studying variables in their natural state, they're great ecological validity. They're very applicable. The findings are very applicable to real world settings. And again, hold that thought before we do more with ecological validity. The limitations are basically you can't establish cause and effect. You have an isolated independent variable. We'll go into what random assignment is, but again, just write down the italicized component on the slide. Okay. There's no control group, there's no baseline, you're not comparing a control group versus an experimental group. You just can't do that, and you're not establishing cause and effect. That's the biggest limitation of non-experimental research. Okay, I'm going to just give you a minute to make sure you have the 4 benefits. Don't write anything more about ecological validity yet. And the limitation. Okay, so I'm going to explain ecological validity a little bit more. So we want to make sure, or if you're evaluating the ecological validity of a study, you want to examine whether or not the conditions, the tasks, what you're measuring, anything that you're using in the study actually mirrors the complexity of what happens in the real world. Okay. To the extent that it does, we say it has high ecological validity. In other words, whatever findings you find are likely to also be found in the real world. To the extent that there's low ecological validity, it means that it's unlikely that if you go out to the real world that this would be true. Okay. So I'm giving you some examples here of studies that lack ecological validity. Here's one. If you are doing a study in a laboratory and you ask people to memorize a list of completely unrelated words in a quiet lab setting, okay, it does not reflect how people use memory in their daily lives, because in your daily life, you obviously get distracted. You might need to recall information very, more than just that one task. So memory studied in a lab already lacks ecological validity because it can't really mirror all the complexities of everyday memory. Driving time reactions often what researchers use as some kind of a simulator. And obviously using a simulator like a mouse to represent driving is not ecologically valid. Real world driving involves using your steering wheels, your pedals, and lots of other distractions that can't be replicated in the lab. So often the issue with laboratory results is that they lack ecological validity. Non-experimental results often have greater ecological validity. So if you can't use non-experimental methods to establish cause and effect, other than ecological validity, why else would you use a non-experimental method? Sure, it's great to make sure that these results might be true in the real world, but then again, we're not establishing cause and effect. But there's another reason, and it's because some variables just can't be manipulated. So let's take a look at examples of variables that no matter what we do, you will never ever be able to put them into a laboratory setting, manipulate them, control for them, etc. So for example, it is a relationship between how tall a man is and how much money they make. So taller than average men will earn more money in their lifetime than a shorter than average man. Now, I may collect data on that and find that it appears to be true. That does not mean that there aren't some very small statured men who make a lot of money. But there does appear to be a relationship between the two. But here's the thing, I cannot manipulate a person's height. I can't randomly assign people to be short or tall. I can't have a control group of people and say, okay, all of you are going to be short and all of you are going to be tall. Can't do that. Okay, so that's an example of a non-manipulable variable that we would obviously use a non-experimental research method to study. Here's two others. Girls learn better in a single-sex classroom than boys. Obviously, you cannot manipulate sex assigned at birth. Children who are abused by their parents are more likely to be abusive to their children. Again, we're not going to ethically be able to manipulate which children are raised by parents who are abusive and which are not, and then follow them later in life to see if they abuse their own children. These are examples of non-manipulable variables. Pretty much any kind of demographic or person-centered characteristic is not manipulable. Your eye color, your height, your weight, your family status, your socioeconomic status, your educational status, your parents' educational status, your immigration status, these are not manipulable. You can study them, but you can't take control of them. So any kind of study that uses those variables will always be a non-experimental research method. So let's take a look at some of the non-experimental research methods that you're going to be responsible for not only being able to identify, but also to recognize, to recognize. Case studies, naturalistic observations, and meta-analyses. We'll start with a case study. A case study is an in-depth investigation of an individual, or potentially a small group of individuals, who have a highly unusual trait. Now, I'll give you some examples. We're not going to watch these videos till I return. Phineas Gage was a man back in the 1800s. A tamping iron, which was used to tamp down, I guess it was like explosive material to build a railroad. It got shoved, got blown out and through his left frontal lobe. So he lost his vision. He remained alive, but we learned a lot about what happened when your left frontal lobe gets damaged. That was a case study. Jeannie, she was locked up in a room by her parents who thought she was intellectually disabled, and they didn't allow her to speak. They didn't allow her to move. She was rescued by the authorities, I think when she was about 12 or 13, and she never really could learn language. And so it really gave researchers in psychology an opportunity to see what happens when you are deprived of certain features in your life, certain stimuli in your life. Will you ever regain function? The case of H.M. was a man who had to have a part of his brain called the hippocampus removed. His hippocampus was removed and he could no longer form a new memory. So this was another case study. So case studies are basically important because they allow us to study unique qualities, unique situations. There's no unethical treatment, which you can't really see there in the slide, but there is no unethical treatment, like all non-experimental research methods. And of course, these individual cases can generate ideas. Hey, wait a second, is that hippocampus really important for memory or not? The cons are, of course, you can't generalize the results. You can't take the result and say, oh, this would be true for everybody. If anybody got locked up in their room for the first 13 years of life, they wouldn't be able to learn language. If anybody had a pole shot through his left lobe of his brain, they'd all go through similar personality changes as did Phineas Gage. So you can't actually say the same would be true for different people. The other con about it is it's really time consuming. Case studies don't really gather quantitative data. They're doing a lot of structured interviews. They're like talking to people, they're getting information, but it's not a lot of quantitative data, so it's very time consuming. Okay, you might need to pause here while you finish writing this down. I'm going to, if Mr. Templin is pausing, I'm just going to see if I can get this to look a little bit better, but I don't think so. Okay, I'll do that later. Okay. Okay, if you've finished doing it or if you need to pause, go ahead. I'm going to move on to examples of case studies. So here's an example of a case study other than the ones I just gave you. Identical twins separated at birth. There's very few of them, but those that are interesting to study. We can take a look at their differences because we know identical twins have identical genetics, but the extent to which they're different is likely due to the environment in which they were raised. Another example are people that are born with a rare genetic disorder that disrupts their ability to feel pain. If you ever read the books, The Girl with the Dragon Tattoo series, there was a man in there, the villain, who could not feel any pain. That's a rare genetic disorder. Individuals who are able to remember every detail of their life. It's called hypermnesia. Now, it sounds great, but these people are tortured throughout their life. They can never forget anything bad that's ever happened to them. And that's an example. These are examples of case studies that might be studied by psychologists. Okay, the other type of non-experimental research you need to be able to identify is a meta-analysis. That is when a researcher goes and they look at other research and they use the statistics from these other researchers and they combine them from like 2 or more studies to come up with their own ideas or own conclusions. Now, it's really easy to recognize a meta-analysis, and I'll show you that on the next slide. But the pros on using a meta-analysis is that there's a lot of data, and the more data you have, the more accurate your results. Often there are controversies, like you might investigate 3 different studies, and 2 of them are different, come to a different conclusion than the third. But in the meta-analysis, you identify why perhaps there is a difference. Maybe they operationally define their variables very differently. And the applicability is, the cons are applicability. In other words, it's usually these other studies, there's a limited sample size. There might be variables that one study studied and the other one didn't. But I think the more important thing is that you understand what a meta-analysis is here, and that it is the statistical combination of lots of studies. And I'm going to show you, so if you don't write all these pros and cons down right now, I'm not too worried about that. But I do want to show you an example of what a meta-analysis would look like, so you could see if you were reading, and if you were reading a synopsis of something, if you would be able to tell if it's one. So here it is. Now, obviously, I'm saying it's a meta-analysis, but here it is. This meta-analysis investigated the relationship between sunscreen use and the incidence of melanoma. A Medline search identified 8 randomized controlled studies examining the effect of sunscreen on melanoma development. Each study involved between 100 and 120 subjects. The analysis pooled the results from all 860 subjects and revealed a statistically significant 50% reduction in melanoma diagnosis among those who regularly used sunscreen. So that's an example of, a small, at least a summary of a meta-analysis. Okay, that's typically what's done. They wanted to see if really sunscreen use was important to deter melanoma development. It appears it is. Okay, naturalistic observation. Exactly as it sounds. It's when you observe and record behavior in the natural setting. You're not manipulating the situation like a case study, because a case study, you may not be manipulating it, but but the people know that they're being observed. But in a naturalistic observation, people don't necessarily know they're being observed. In fact, hopefully they don't know they're being observed. Now, obviously that has great ecological validity, okay? It includes all the complexities of everyday life that could affect behavior. So that's why it has great ecological validity. In fact, all you really need to write down is like that really high ecological validity. Okay, there's no doubt about that. But of course, when there's no manipulation of variables, so there's no cause and effect, it takes a lot of time. And the other thing is, if people know they're being watched, and that is always the risk in a naturalistic observation, they may actually change their behavior. They want to feel like you like them more, so social desirability bias. They want to maybe conform to behavior they think you expect of them. And we'll define these terms, social desirability and participant bias, in a bit. But a naturalistic observation, the person is typically away from the individuals that they are observing. Those people being observed are not aware, hopefully, that they are being observed. So it's truly a natural setting. Okay. And remember, in a case study, obviously the people know they're being observed. Okay. In a meta-analysis, the people, at least in the original studies, knew that they were being observed. But in naturalistic observation, hopefully nobody knows that they're being observed. Okay, here's some examples in psychology. Darwin actually observed his own children. Now, they were infants, so they didn't really know they were being observed, but he recorded his infant son's facial expressions, his social behaviors, and he provided some early data on early naturalistic data on like emotional development of young children. Okay, they didn't know they were being observed, I say, for that reason. Psychologists have often put themselves into a grocery store, some kind of a setting like that, and they observed how parents manage tantrums, how they bargain, and how children comply in public settings. And they like to do that in order to study maybe the discipline styles and how that actually impacts child behavior regulation. Now, obviously, it's not a cause and effect study. It's a naturalistic observation. But by putting themselves in a store like that, where there's lots of distraction, the people being watched may not know. Now, they'll have to spend a lot of time observing lots of interactions, recording them. You can imagine it's not a lot of quantifiable data. It's a lot of qualitative data, right? They're just writing down, describing what's going on. Okay, I'm going to stop here because I'm sure this was a short day. Thursday, we're going to talk about correlational studies. We'll actually do on Thursday our first .p activity. So you'll need that activity packet that's in the on the front of the room. If you don't have that, please pick that up, but you'll be doing 0.p.1 in class. Please, again, don't work ahead. It's more fun to do it together, and there's certainly no reason to give yourself homework when there's no homework to be done. And I do hope to be there on Friday, but can't tell quite yet. And I hope everything's going well. But again, please contact me through Canvas or through Synergy if you have any questions. And I hope you have a great day.